Good morning, Phantom community. You've got Sam here, and in this video we're going to have a look at filter blocks. This video is a continuation and the second part of our decision block versus filter block deep dive, and I'm making the assumption you've already watched the decision block video. Okay, so when we look at the blocks available, we can see the filter block with a more or less standard filter icon. Of course, this is the block of interest for this video, so let's discuss it in isolation for a moment. When we drop in a filter block, we can see that the standard advanced setting, common to most blocks, is available. But because we've covered that before, we're going to ignore it here. More to the point, though, are the conditions. These do look quite a bit like the decision block's if statements, but they're fundamentally different in a few ways, and we'll discuss those momentarily. Like decisions, filters can have up to 5 independent configurations, each represented by a circle of a different color. We can see that once we have 5 conditions built, we no longer have the ability to add new elements. Also, like decisions, we can have compound conditions for each section, and these can be joined by and or statements, but not both. Now again, this aspect was covered in the decision block video in greater detail. Finally, notice that there's no else condition. That means that out of the box, you're looking for positive matches. You could, of course, construct a catch-all condition, but if you find yourself doing that, then I would urge you to carefully consider the design of your playbook. So this is how filters are put together at a high level. But what do they actually do? Well, a filter is going to run every condition when the block is called. So, unlike decision blocks, if there's a match, it doesn't affect the execution of the block. It will keep running until all conditions have been checked. And furthermore, it's possible to have an artifact or an action result go down multiple branches of the condition paths if they match more than one condition. So let's take a look at this in practice. Here I have an event set up with 2 artifacts. The first artifact has a source username field with a value of Rob and a source DNS domain field with a value of phantom.us. The second artifact has a source username field with a value of Sam and a source DNS domain field with a value of splunk.com. So for the purposes of illustration, our playbook will utilize this event. I've put together this small playbook for us to use while talking about filters. In our filter, you can see that I've got 2 conditions configured. Condition green looks for splunk.com in the source DNS domain field. Condition purple looks for phantom.us in the source DNS domain field. These filtered results are passed to 2 custom functions as input parameters. I used custom functions so we could easily observe the output in the debug window, but you could of course attach them to any block. A quick peek at the custom code blocks shows really only one line of code each. A debug statement printing the artifacts and which block the statement came from. Incidentally, I will get back to how these work in much greater details here shortly. Alright, when I run this playbook against the event that we looked at the beginning of this section, we can see that the green function received its filtered artifacts, and the purple function received its filtered artifacts. But this brings up 2 questions. Number 1, what would happen if there were no matches? And number 2, what happens if there are multiple matches? Let's explore question number 1 together. So we'll do this by changing the condition 1 to not match any value from our artifacts, and then we run this again. Here we'll see that the downstream block is never even called, and that's because there's no match. Remember that there's not an else condition available out of the box, so unless you're being very creative, that's the end of the line for that artifact in terms of this filter. For question number 2, what happens in the event of multiple matches? So let's create a new condition and a code block to explore this. First, we're going to change our condition back to the original state. We'll add a new condition where we just look for the letter U in the source DNS domain, which will match both splunk.com and phantom.us. And then we're going to create a new custom code block. Pass in the filtered data as a parameter. Change the name to orange. And put in our debug statement. Now, when we run this, we can see that green gets its filtered data, purple gets its filtered data, and orange gets both. And this is key. Matching values in a filter can trigger several paths to execute, and those separate paths may get the same value. It's easy to think of this as the data being passed down the connection to the downstream block, and that's generally a good enough explanation. But since this is a deep dive, technically that isn't precisely right. A more rigorous description would be a matching filter causes a filtered name to be available in the data path, and the resulting connected block gets executed. Let's talk about how these work at a deeper level. As always, we're going to do that by diving into some code. When we use filter blocks, a function is created in the Python code for that filter. The primary Phantom API used within these functions is the phantom.condition. The documentation online and in the product do a good job of describing this function, so we won't go into too much detail, but high level, phantom.condition is used to match filter expressions to find artifacts or action results. These conditions within the phantom.condition API call correspond directly with the UI elements for the filter. As you modify the UI filter, these elements will be updated in code. When a match is found, the artifact ID or matching action results are returned. And you can see here where these variables get assigned in the code. A key feature of the filter block is this name parameter is passed to the phantom.condition call. This tells Phantom to save the filtered results such that they can be referenced later by downstream blocks. Here in our code, you can see that the name is filter_1:condition_1. And in the next block attached to that condition, that filtered data is available for selection by name. The very next piece of code is where we check if we had any matches in the condition. And if we do, then we call the downstream block with all of the appropriate parameters. Here's the thing to notice. There's no return statement after the block is called. That's why every condition is run whether or not there's a match. All these tests happen every time the block runs, and only at the very end of the block do we see a return statement. And we can see this pattern is repeated for every condition we've defined. So how is this data used? If we look at our downstream custom functions as a reference, we can see that when we pass in the filtered data as a parameter, in the blocked section of the function, code has been generated for us mostly using the phantom.collect2 API and specifying the data path. Remember, this data path is only accessible because the condition block had the name parameter, which saved it for us. The second line of code simply unwraps the field we want into its own separate list. And this is necessary because collect2 returns a list of lists. Let's have a quick look at that. Let's add another 2 debug statements printing those values. When we run this, we can see that the first variable, filtered artifacts data1, is indeed a list of lists. And the second line turns that into just one list. Why? Well, in this block, I only have one input parameter, so it may not be so obvious. So let's add another. Now, when we run it again, we can see that the variable filtered artifacts data1 is still a list of lists, as we've said, but each of the inner lists contains, in order, the parameters requested from the artifacts, or the action results. That's why the next lines of code are needed, to extract the various elements of the inner lists representing the elements of the data path, and then putting it into its own list for our consumption. I know we jumped into the deep end of the pool on this one, but I hope you all found it helpful and enlightening, and I look forward to seeing you next time.